So, good morning, children. Welcome to this session. Hope you all must have utilized these 3 days of break and then must have revised all those hydrocarbons which we have discussed, isn't it? So, if you can recall, what were the three types of hydrocarbons? Ane, saturated, ene, unsaturated, double bond, ine, unsaturated, triple bond, isn't it? And we learned how can we draw the structures. Okay, hope that you must have completed the remaining five structures of all these hydrocarbons. So if you have seen, we have drawn the structures which are very elaborate, in the sense representing the number of carbons, the number of hydrogens present in each of the hydrocarbon. But as the length of the carbon chain increases, this becomes very tedious process. Okay, so in order to reduce the time and that effort, the formulas of these hydrocarbons can be written in a very short form, which is also called as the condensed formula. Now what you're all seeing, these are all nothing but what formula? The structural formula. What are all these, children? Structural formula. Then now let us reduce it, okay, such that it makes our work easier. So let us begin with the first case, that is, what is the first hydrocarbon under alkane? That is methane. So methane, so how many carbons, children? Let us first write a single carbon, then represent hydrogen. How many hydrogens? 4. So the condensed formula becomes what? CH4. Now let us come to the second hydrocarbon. What is the second hydrocarbon? That is eth group. The root word is what? Eth, if you can recall. And what is the compound? Ethane. So first, in order to write the condensed, now this was easier. Now from here we have to do the actual work. In order to write, first you have to place the number of carbons. Now in eth, how many carbons are there? 2. So let me represent both the carbons. Now each separated by what? By a single line. In the sense they are bonded with a single line. What is this line representing? The bond. Now count the hydrogens for each of the carbon. So how many hydrogens are there for the first carbon? 1, 2 and 3. So let me put it as CH3 or H3C. Either way you can keep, children. Then come to the second carbon. How many? 1, 2, 3. So CH3. So what is now the condensed formula? CH3, CH3. If I further condense it, which the formula which you have all have learned, it is what? C2H6. Okay, children. Fine. So now let us see for the third case, that is propane. So as usual, first of all, represent the carbons with a single line, indicating what? A single bond. Now arrange the number of hydrogens. So how many hydrogens for the first carbon, children? 3. Now let us count for the second carbon. 2. So CH2. Now for the third carbon, CH3. So now how is the condensed formula written? CH3, CH2, CH3. Okay. And further, when it is condensed, it is written as what? C3H8. Similarly, come to the hydrocarbon with 4 carbons, that is butane. So 1, again follow the same steps. 1, how many carbons, children? First 4 carbons, since it's a butane. Okay, then 3 and then 4. Okay, now arrange the hydrogens. First carbon, how many? 3. Second, 2. Third as well, 2. Okay, then fourth, CH3. Okay, so CH3, CH2, CH2, CH3. Further condense, the formula becomes C4H10. Okay, then similarly come to fifth, 5 carbon hydrocarbon, that is pentane. Represent same. Follow the same procedure. Write all the carbons first, each bonded with a single bond. And how do I represent that single bond, children? With a single line. So 1, 2, 3, 4, 5. So first carbon, how many? By this time you must be able to do it now. CH3. Second carbon, CH2. Third carbon, H2. I can write either onto my left side or right side. Doesn't make a difference because anyhow it is understood that these hydrogens are associated with this particular carbon. Then come to the fourth carbon also, CH2. Fifth carbon, CH3. So CH3, CH2, 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 CH3. Further condense, the formula becomes C5H12. Fine, children. So now similarly we can also construct the formula of the condensed formula of alkene as well on the same line. But what would be another added point? Yes, a representation of a double bond. And where will I represent the double bond? Wherever it is existing. Now right now we are placing it only between the first and the second carbon. While the structures, when you are going to learn in the higher classes, you will know that double bond may not be always on the first and between the first and the second carbon. Okay, but for our convenience right now we are placing it between whom and whom, first and the second. So now shall we draw the condensed formula for all these children? Yes. So now let again say, represent first with a single line between the carbons. Now, but it is a double bond hydrocarbon, so I will represent one more line. And then how many hydrogens for the first carbon? 2. Second carbon, 2. I hope now children you are with a pen and a paper and you must be practicing along with me. So if you practice along with me, you will easily get them. Okay. Then now what is the condensed formula? CH2 double bond CH2. Okay. And then if I further condense, which you already have learned, C2H4. Okay. And you all know that there is no compound of ene or yne, as because there is no double bond or a triple bond should be between carbon and carbon, which is not possible with a single carbon. Okay, so the first hydrocarbon of alkene is ethene. Similarly, first hydrocarbon of alkyne is what? Ethyne. About this we'll be talking a little while later. Then now come to the second hydrocarbon of alkene. Second hydrocarbon I'm saying, but with how many carbons? 3 carbons. So what is this? Propene. Okay, so again step 1, what children? First arrange the carbons with how many lines? Single line representing what? Single bond. Then arrange the bond, double bond. Then third, step 3, arrange the hydrogen. So first carbon how many? 2. Second carbon how many? Only 1. I can place either this side or that side. Third carbon how many? 3. So CH2 double bond CH3. So what would be the formula? C3H6. Okay. Now come to fourth, that is butane. So 1, 2, 3, 4. Same steps again. First carbon how many? The second step is what? Place a double bond. Then number of hydrogens 2. Here how many? 1. And here how many? 2. Here how many? 3. Okay. Then now CH2 double bond CH2 CH3. So further condense, it becomes C4H8. Okay. Now let us come to the fifth case, that is pentane. 1 as usual, 2, 3, 4 and 5. First carbon, then place a double bond. How many hydrogens children? 2 hydrogens. So second carbon, single hydrogen. Third carbon, 2. Then 2. And the final one, 3. Okay. Now further condensed, it becomes C5H10. Okay. Now let us see for what? Alkyne. I hope now you must have understood how to do. And again follow the same steps. So what is the first hydrocarbon of alkyne? Ethyne or acetylene, commonly called as what? Acetylene. Same step again. Draw a single line. Now how many I have to represent? A triple bond. So 1, 2. So 3. So now again arrange the hydrogen. So how many? 1. Here how many? 1. So CH triple bond CH. If I further condense, the formula becomes C2H2. Okay. Then come now to the next case. Second case, that is propane. So 1, 2, 3. Now what is my second step, children? Yes, placing the bond. Which bond? Triple bond. Now arrange the hydrogen. How many? 1. Second carbon, no hydrogen, because all these electrons are satisfied between the carbons and the carbons. So then come to the third case. Third carbon, how many? 3 hydrogens. So that if I condense, I will be putting it as water, CH2. Okay, you can, I just made this mistake, children, ignore it. So CH3. Fine. So CH, triple bond C, then single bond CH3. Okay, so condensed formula will become C3H, how much, children? 4. Now let us go to butane. 1, 2, 3, 4. Step 2, yes, arrange the triple bond. How many hydrogen? A single hydrogen. Second carbon, how many? No hydrogens. Come to third carbon, 1 and 2. So CH2. Then let me arrange the bond. Then fourth carbon, CH3. Okay. So further condensed, the formula becomes C4H6. Okay. Now let us come to the fifth one. The fifth 5 carbon hydrocarbon. That is a fourth hydrocarbon under alkyne. So 1, 2, 3, 4 and 5. Second step, yes, place the triple bond. Now arrange the hydrogen. How many hydrogen? Only 1 for the first carbon. Then second carbon, no hydrogens. For third carbon, 1 and 2. So that means total how many, children? CH2. Then fourth hydrocarbon, again 2 hydrogen. So CH2. And then the final fifth one, it will be CH3. Okay, it will be CH3. Then the further, so CH triple bond C, CH2, CH2, CH3. Further condensed, we can write it as C5H8. So now